it's pretty neat demo. It's just fun to play with. When I see things like that in the browser, I start thinking, hey, maybe number crunching is not a stupid idea. The guy who did that moved a lot of the computation to the GPU, but you cannot move everything to the GPU. You still have to do some computation in JavaScript. So if you look, don't worry, if you look at this function, for example, it looks a bit strange. There's no loop, there's no function call, it's just entirely flat. And it's a lot of duplicated code. Many lines look the same, only the numbers and indices change. It's actually a little bit like loop unrolling. You can ask yourself, why would someone write code like this? Actually, it's all about performance. It's a lot easier for the engine to optimize code like this. Or like this one. This is a matrix multiplication. And you don't have a single loop here, it's already unrolled. So I'm only quickly going to show how we can generate such code automatically. There's an implementation there, you can play with it if you're interested. I'm only going to give you a feel of this. Instead of computing values, which can be expensive because you have the code stack to maintain, we compute expressions. So at this point, we only have to wrap a function with a little wrapper. And it doesn't return a value, it returns an expression. And the code I wrote can generate for you optimized code, which in this case, it's not very exciting because you cannot optimize more than that. But you can build on top of that. For example, let's add two complex numbers. We can still write it in a clear way, very encapsulated. And if we just transform our code a little bit using this wrapper, and instead of adding values, we just return expressions, then very optimized code will be generated for you. So this generated function doesn't have any function call, and it's very flat. So these computations are very cheap. You can go further. For example, these are a few additions and subtractions of complex numbers. The details that don't matter. What's important is if you want to write this clearly, you have to write many function calls, which is very expensive. So instead of doing this, you wrap your code with this little wrapper, and it generates an optimized function for you. The point is that this code is still very readable. You can still understand what's happening here. And the generated code is very flat. It does a few intermediate computations for you, and very cheap. This here looks a bit stupid, but you have to think how much effort it would be to further optimize this, and how little it would bring. We have already done most of the work because we have eliminated function calls. I think I just keep these ones. The one interesting example is if we go much further, discrete Fourier transform. Okay, that's way too much code. This way, I guess. It's a bit better. I won't go through every line of the code, doesn't matter. The point is you have code here which compute some math on a vector of numbers, and it's defined in a recursive way. This is exactly the way the algorithm is defined. So you just pick the paper or pick the Wikipedia page and just write it like that. And the big difference is that at the end, you return an expression. You don't return a value. So your code is very similar as if you would have written it normally, but with this little change, you can have it optimized for you. And the result is a very flat, cheap code. It's doing the computations in the right order, so it's never doing twice the same computation. And you're expecting another vector of numbers, so it's there. And you have completely eliminated the recursive codes, which are very expensive. I did some speed tests, and on the left it's a small matrix multiplication problem which was optimized this way, and on the right you have various sizes of the Fourier transform. You can see that it's a huge speed up, except in some environment, the first time we call it, it's a bit slow. But I guess afterwards the JavaScript engine optimizations are triggered. You have to understand here, you may have half a megabyte of code generated for you. So that explains. But afterwards, it's pretty neat, it runs pretty fast. And I haven't had time to try that, but I did try to add some format information here and generate C code. And in C, I observed a big speed up as well. And a rule of thumb is you gain about an order of magnitude in JavaScript if you do this optimization. And if you do it in C, you get, again, an order of magnitude. And now I'm wondering if we produce code which is compatible with ASM.js, how fast would it be? And we could be very close to the C code speed. I think this can open many things, also on the server side. Well, that's it. Thank you very much. Question?
Hi, does this flatterize of you generate already an ASM.js compatible code, or is this a future task?
It's a future task, but what's already possible is to generate C code, and for that you just insert here some type information. For example, you say, I have an array of floats. So I think we could just change this code a little bit.
And then you transpile C code into ASM.js.
I would just completely skip that. I would just take the implementation, because the implementation which produces C code is actually JavaScript. So I could just do a clone. Or maybe someone. Maybe you? Okay. Thanks. Any other question?
Two questions actually. One is that have you tried trying to analyze language through a static language analyzer or lexer? So instead of intertwining the actual code with your library, just fully parsing it. And the other one is that have you compared it or did some comparisons with ASM.js and NACL? Without them, is this comparable?
Can you repeat the first question?
Yeah, right now your code is have to be used with the source code itself. Have you thought about, or would it be too much, too complicated to parse up the source code through lexical
it's a good question, but you have to be sure you are doing a math computation, because there are also some very simple simplification. If you get at some point, when you're developing the expression, if you get 0 times something, you just drop it. If you have just any code, and you're passing it, I haven't tried that, but I guess you would need to enforce some constraints. So it would be probably just a subset of JavaScript. Yeah. Now, the question about ASM.js, I guess it comes to my last point. I guess the point would be to try the original version with ASM.js, with the recursive calls, and the flat version also with ASM.js. That would be a good idea, yes. Thank you. Yeah. Okay. Well, thank you very much.